Hi guys, I'm back again. This is part two. Sorry I had to do it in two parts, but I can only post 15-minute videos to YouTube, so I wanted to make sure you could hear it all. When we did part one, I asked you to go through, I'm going to scroll up here, and to try, we did numbers 1, 2, and 3 together from Proofs Congruent Triangles number 1. And then I asked you to try 4, 5, and 6. And then to come to this page and check it. So if you have not already done that, please go ahead and do that right now. I wanted to show you one thing. I'd like you to take a look at review of triangles. It's also in your packets. Numbers 1 to 19 are all just the same kind of stuff that we did with triangle sum theorem and exterior angle theorem and isosceles triangles and all that kind of stuff. And then number 20 is just writing a congruency statement, making sure you have the letters in the correct order. So like if you were to say triangle DMZ is congruent to, you need to make sure that the correct angles on the right side match those also. And then 21's a proof. So if you want to also go ahead and try those, that would be very helpful to you for your next test. And the answers to that are posted on Engrade with the rest of the homework. I'd like to take a look now at congruent triangles number 3. This is the last lesson in your packet. I wanted to take a look at the different proofs. These are all dealing with parallel lines and proving triangles are congruent. I was going to try numbers 1, 2, and 3 with you now. I'm going to go over them here. And then again, I was going to have you try 2 more, 4 and 5 completely on your own and then check those on your own. Okay, so let's take a look at numbers 1, 2, and 3. It's very similar to the last time. You just have to use those properties that we've been learning throughout about parallel lines and triangles and bisectors and everything, okay, to be able to show that two triangles are congruent. So let's start with number 1. We're given that EF is parallel to GH. Okay, so now that we know they're parallel, all of the properties that are true of parallel lines with a transversal crossing over would be true with these. And we're also told directly that EF is congruent to GH. Now that's a freebie. You don't have to explain that in any way. You just literally mark them congruent, and then you can use that later on to prove that the triangles are congruent. Okay, so start off by restating that, and that's your given. All right, now we need to work off of the given. You actually have two options here. Notice that the angles that meet at K are vertical angles. If you want, you may name them first as vertical angles and then state that they are congruent by the vertical angles theorem. That's fine. It's more steps than what I'm going to show you, but it is correct, but it would change this answer from ASA to AAS. So just make sure you're clear on that, okay? But what I chose to do was I chose to say that since this line is parallel to this line, then thinking of FG as a transversal, then I named, that's really sloppy. Let me see if I can fix that here. If I think of FG as a transversal, then I named angles EFK and angles KGH as alternate interior angles. And I also named, because of this transversal, angles FEK and angles KHG as alternate interior angles. And the reason why I'm allowed to call them alternate interior angles is because that's the definition of alternate interior angles, much like we did in the last unit. You must name them first, and the reason is the definition of that type of angle before you can state their relationship in part 3 that the pairs of angles are congruent. If you don't first say, hey, these are alternate interior angles because that's the definition of alternate interior angles, it doesn't work. Okay, so just be really careful on that. Once you have now defined them as alternate interior angles, you can now say, well, now that means angle EFK is congruent to angle KGH, and also angle FEK is congruent to angle KHG. And that's because of the alternate interior angles theorem, which again, we learned about last unit. If you need to pull those theorems from parallel lines, feel free to do so. But it says that if you know they're alternate interior angles, then you can say they're congruent. And since we're trying to prove triangle EFK is congruent to triangle HGK, you can see that we have 3 parts, an angle, a side, and an angle that are congruent in each triangle. So we now have the right to say the triangles are congruent by ASA. Okay. So again, very similar to the other stuff that we just did. Lots of the same thing and just lots of stuff that you've been seeing over and over again in all these different proofs we're doing in all the units. Okay, number 2, we're told that segment TX is congruent to segment SY. Or I'm sorry, is parallel to segment SY. So again, if you think about extending those lines, and then this is going to be a transversal going through them. Okay. And then we're also told that angle X is congruent to angle S. And again, that's just a freebie. No words are used, so there's nothing to define it. It's just to mark them and you're done. Okay, now, just like last time, we know that if the lines are parallel and this is a transversal coming through them, we know that we can say that we have pairs of alternate interior angles. We will define them as such, and then we can say they're congruent. But in this case, if all you do is show that this is alternate interior to this, and this is alternate interior to this, and they're congruent to each other, then you're only going to be able to say that the triangle is congruent by AAA, which we know is not possible because that's not one of the triangle congruence theorems. So you're welcome to identify both pieces if you want to. And then you could even make the middle side congruent to itself and then say the triangles are congruent by ASA. Or since you already have these pairs of angles out here that you were told in the given are congruent, you could just choose to identify one set as alternate interior, which is what I did. Okay. I just picked and said, okay, well, I'm going to say angle XTY and angle SYT are alternate interior angles because that's the definition of alternate interior angles, that they're on opposite sides of the transversal in between parallel lines. And now that I've identified them as alternate interior angles, I can now say that they are congruent, like I did in step 3. So angle XTY is congruent to angle SYT by alternate interior angles theorem, which says if you know that the lines are parallel and you've identified them as alternate interior angles, then they are congruent. Now, I need a third piece in each triangle, and it can't be the third angles. So I noticed that they share this side in the middle. So I said by the reflexive property, side TY is congruent to itself. And now I have enough information to say that triangle TSY is congruent to triangle YXT because of angle, side in this triangle and angle, side in that triangle. Okay? There's more than one way to do it. If you had decided to make this set of angles congruent to this, you could also do ASA. So when I grade these things on your test, I have to read them carefully. But if it takes more work, you're welcome to do it, but you certainly don't have to. This is the least amount of work the way I'm showing it. Okay? In a minute, you'll look at these again to try and get another good feel for it and just to try and play around with them a little more. Okay? But first, let's try number 3. In this triangle, we're told that Z is the midpoint of segment CT and Z is the midpoint of segment EY. Prove that triangle EZC is congruent to triangle YZT. Okay, so start with the given, restate it, and then take the words in the given, which are midpoint, and explain what that means. So if Z is the midpoint of CT, then that means that segment CZ is congruent to segment ZT. And if Z is the midpoint of EY, then that means that segment EZ is congruent to segment ZY. And why? Because of the midpoint theorem. So that's statement number 2. We're trying to prove that triangle EZC on the top is congruent to triangle YZT on the bottom. We need one more piece in each triangle since we right now only have 2 pieces in each triangle. And I can see that these are vertical angles and would be congruent, but don't just mark them congruent. You have to first state that they're vertical angles because they have not been defined as vertical angles in the problem. So statement 3 is defining them. Angle EZC and angle TZY are vertical angles by definition of vertical angles, that they're across from each other with intersecting lines. And so now I'm allowed to say that triangle EZC is congruent to triangle TZY by the vertical angles theorem. Vertical angles theorem says once you've said they're vertical angles, you can then say they're congruent. The top triangle, we have 2 sides and an included angle. In the bottom triangle, 2 congruent sides and an included angle. So we can now say the triangles are congruent by side, angle, side. Okay. All right. So what I would like you to do is the following. I would like you to go through and I would like you to try these 3 again on your own. This time without, you've seen them, so they should be pretty fresh, but try them again, see if you can do them, and then check your answers. And then come down and try numbers 4 and 5, which are very similar, and check the answers to those too. Also, in addition to all these triangle proofs, I would like you to go back through and I would like you to try review of triangles, which is in the homework section of your packet, numbers 1 to 19, and then 20 and 21. All of this together should help you to get ready for the test that's coming soon. And then in class, we can go over just like little bits of everything and tie together the stuff before Christmas and the stuff after Christmas, answer any kinds of questions you have and try to get you ready. Thank you for your time.